All right, so this is, by the way, what I'm about to go over does not fully comprehensively answer every question you'll have on the new worksheet. Like the last problem on this worksheet is pretty tough. You've been warned. So challenge issued, problem 7. But that's not what I'm going to go over with you. I'm going to go over problem number 1. So this is on worksheet. Yes, I know it's assignment number 44. But the worksheet, like as you ask me questions today, make sure you tell me, like, I'm on page 51. Like y'all see how the worksheet has like a page number at the bottom? That's the page number that when it came out of the notebook. So as you're asking me questions today, just don't say like, can I get your help on number 4? Like that's pretty vague, right? So we're doing page 51 right now. And I just thought we would go over problem number 1. So listen, this is not a lecture because I already taught you how to do this in a lecture from before, but it's just been long enough that I feel like it would be unfair for me just to throw this at you and say, good luck. So you might remember that on some of these problems, we're not always looking for people's ages. And I could tell that right away. Like when I look at problem number 1, like imagine if I said, let K equal Mr. Klinker's age. Like, why would I do that? Like, I already know he's 35, or like, if you say, okay, well, then let D equal his dot. No, I already know she's 10. So do you guys remember in problems like this, what it is actually that we're looking for? No, kind of. Read on in the problem and hopefully it'll come back to you. I never gave you an assignment on this yet, but this was in the lecture on age problems. Say again? Yeah, we're looking for a number of years. So basically in these problems, like we need to know either how far in the future we have to go to make something be true, or how far in the past we have to go to make something true. And I can tell which is which because I speak English and read it relatively well, as do you. So because it says in how many years, we know we're going into the future. So let's start with our variable declaration. And we're just going to say something like let x equal the number of years. And you could put, if you wanted to be a little more specific, you could say like in the future, right? You wouldn't have to put that part if you didn't want to. But we do not have variables that pertain to the people's ages because, again, that would be really weird because we already know their ages, right? So what we're trying to accomplish in these, and this is the same as problem 1, 2, 3, 5. In those problems on this page, we already know how old the people are. So this is kind of the model that you can use for those. What we're trying to accomplish is, and I'm going to use just kind of words for this, is according to this, I want to know when will Mr. Klinker be twice as old as his daughter. I find that to be helpful because it keeps me and it keeps my students especially from multiplying the wrong thing by 2. So somewhere in the future, this will be true. And let's talk about that. How old is Mr. Klinker right now? 35. How old will he be in the future? Nope. He'll be 35 plus X. So just bear this in mind that as we talk about Mr. Klinker in the future, yes, currently he's 35 years old. We all get that. But if I go ahead in time, 1 year, 2 year, 3 years, X years, then that, of course, is an addition scenario. So this 35 plus X is the age of Mr. Klinker at some unknown point in the future. That's what we're trying to figure out. It's like, how far do I have to go to make that happen? So hold on a second. So we good on that? That's Klinker's age in the future. And again, we're still talking about the future. So, I mean, equals is equals. And we want him to be twice as old as his daughter. But again, I'm not going to put daughter as like 10. That doesn't make sense. How old is his daughter in the same future? Yeah, same logic. I mean, she's 10 now. At some unknown point in the future, she's that old. We just don't know what X is. That's why it's an algebra. Do you guys have any questions about that process? If it said how many years ago, of course, being in command of our native tongue, we would understand that that means we subtract x because we're going back some unknown number of years. So these are not systems. You might also, if you have a good memory, you might remember that with this lecture, we didn't get two equations. We just get one. There's only one thing we're trying to find out. I don't need two people's ages. I just need to know that number of years to go ahead. One variable, one equation, done. Let's go ahead and solve this out so we can make it official. What would we do first? I would distribute for sure. So I would 35 and x, yeah, I would just leave those alone. And then on the right-hand side, what is 2 times 10 and 2 times x?
20 plus 10.
Perfect. And at this point, we've long since left Mr. Klinker and his daughter behind. Like our concern right now is we're just in there doing math, right? And this should be a real quick process by the middle/end of February. This yellow X is going to go over there, and this red 20 is going to go over there. That's how your brain should start to perceive solving an equation. It's just real quick, flip, flip, put everyone where they belong. How many X's will I have left on the right side?
Yeah.
Just one, because I had to subtract X to get it there. And what is 35 minus 20? Good. So that completes steps 1, 2, and 3. And then it's just time to write a quick sentence, and that is something like, in 15 years, comma, Mr. Klinker will be twice as old as his daughter. And again, I say this for those of you who have decent memories. You might remember that during the lecture, we actually verified this. And you're welcome to. I mean, the chances are, like when you see your answer over on the right side, you're going to probably go, yeah, that feels pretty good. But if you're the kind of person that wants to know, like if this were a test, then you can take their ages and actually morph them 15 years into the future. So Mr. Klinker is currently 35, right? If he goes ahead in the future 15 years, what will he be? Good. And his daughter is currently 10. If she goes ahead in the future, she'll be 25. And it just, I say, maybe it's just me or some of you, I don't know. It just feels good to see that and kind of go, it worked. 15 years from now, that relationship will hold true. So that is how you attack those problems. And again, that was from an old lecture, but it's been a bit. So there's that. At this point, I know that you had a question and you had some questions. I'm just going to kind of leave this going, and you guys may be working on 42. I hope you're not still back on 42, but 42, 43, 44, that's just kind of, we're getting all around today, trying to get everything done. Got it? All right. If you need help and you see that I'm busy with someone else, don't just sit there and wait. Like maybe move on to something else, leave some blank space on your paper and head on to something else so you're not wasting time, okay? Ashlyn, what was your question? Could you give me page numbers? Is that the 171? That's number what? Okay. So this is page 171. Problem number. Well, let's take a look. I like the fact that you already have it done, so I don't feel like I'm doing this problem for you. I'm just going to go in and we're going to try to spot your boo-boo. So I assume you've got K as Kate's age and A as Ann's age. So here it goes. It says 4 years ago, Katie was. The moment you see 4 years ago, Katie was, you should have that. Is that correct? Okay. And it says that 4 years ago, Katie was twice as old as Anne was then. So the as Anne was then, or whatever, that refers to the same time period, 4 years ago. First equation's good? Okay. Second equation says in 6 years, Anne will be. So in 6 years, Anne will be the same age that Katie is now. You good? All right, this is good news. So you knocked step 2 out of the park if you got these equations. Excellent job. My personal preference in a case like this, you've heard me say this last week, is I just am going to distribute here, and I just prefer not to leave parentheses knowing that I'm about to put more in. Like I just feel like that makes me uncomfortable. So I'm going to clean up that right side. And it's going to be k minus 4 equals 2a minus 8. You good? Still? Have you spotted your boo-boo yet? Let me go back and do it the way you did it then. So, because really my mission at this point is to try to figure out, to isolate where you went wrong. So I'm going to do it using your method. So did you use substitution? So you took this and put it right here. Okay. So that's going to be a plus 6 minus 4 equals 2a minus 8. We still good? So still no boo-boo? Did you say not really? Okay. The next thing I'm going to do, because I would be an absolute, I would be contradicting everything I've always said, is if I'm going to combine these two like terms right here. So that's going to become a plus 2. And then at this point, you should just know that a equals 10, like immediately. Did you spot it? What'd you do? Yeah, positive 6 minus 4 is definitely positive 2. So if you take your a and scoot it over there, and then take your minus 8 and add it over there, then you just wind up with a equals 10. And then from there, you can answer any question that you want. You good? Did you want to go over something, T? Well, yeah, that's the entire thing. So, like, you're gonna have to pick a problem because were you absent when we learned this, or you mean page 51? So, what don't we know? I know we take that out of your. I know it's not on, but it can't be in there right now. Thank you. Yeah. So, what are we looking for? Like, what are we trying to figure out? Yeah. So the first job in any word problem is to read it and say, like, what is my unknown? And in most word problems, there's going to be two unknowns. Like Dorothy's age is going to be D and Rita's age is going to be R or something like that. But again, you'll remember this from the end of one of our lectures that it's not always someone's age that we're looking for. So in this case, I need to declare a variable, and I'm just going to go with the generic X. And I'm going to let X represent whatever it is I'm looking for. Like in this case, X is going to represent a number of years. So according to the problem, there is going to come a point, and you get this out of the second sentence, where George's mom will be 3 times as old as he is. Like, you just have to read that second sentence and agree that that's literally what it says, right? So what it's saying is that at some point in the future, the following is going to be true. George's mom, her age, is going to be exactly 3 times George's age. Like what I'm doing right now is not setting up an equation. I'm using words to try to model the situation, because then that gives me sort of like something to connect my math stuff to. So how old is George's mom right now? How old will she be in the future? How old are you? How old will you be in 1 year? How old will you be in 2 years? How old will you be in 10 years? How old will you be in X years? One of the biggest things that we can do to make ourselves better mathematicians is to really, there's a word for this. I don't, it might be like metacognition. I don't know. I hear this kind of garbage at the in the books and stuff. But if I said to you, okay, you're 15 years old, how old will you be in 1 year? Whether you know it or not, what your brain is doing at some level, whether you know it's doing it or not, is your brain is taking 15 and it's adding one when you say 16. If I say to you, how old will you be in 4 years? Your brain is doing this. The trouble with it is we don't often stop to think about that. If I say, how old will you be in 4 years? It's so automated in your brain that you just say 19. Like you don't even really think about the process. When I said to you, how old will you be in 10 years? I guarantee you didn't sit there just now and go 25. Like you didn't do that. Your brain, whether you knew it or not, took the number of years that you currently possess, it added the number of years I asked you to go forward, and you gave me this answer. But rather than focusing on these answers, what we need to be focusing on are the problems themselves. You are 15 years old. How old will you be in X years? Let's go over this again. Now, I want you not to read me these numbers that I've crossed out. You're not allowed. How old will you be in 1 year? Just look at the TV. The answer's already up there. Nope, don't say you're not allowed to say 16, 19, 25. Do not give me the answers. Give me the math problems. How old will you be in 1 year? 15 plus 1 is the correct answer because you're 15, right? How old will you be in 2 years? How old will you be in 10 years? How old will you be in 12 years? How old will you be in X years? That's what I need right there is that sweet, beautiful sound of you saying 15 plus X. You may say to yourself, listen, like, I don't know how many years are going to pass, but that's what makes it an algebra problem. George's mom is currently 37 years old, right? How old will she be at some unknown point in the future? Correct. That's it. Embrace the idea that I don't know what X is. That's the whole point, right? And then we're going to put equals 3. And then in parentheses, we have George. And again, we have the same conversation. I'm not going to ask you how old George is now. I want to know how old is George going to be when his mom is 37 plus X? How old will he be? Correct. Does that make a lick of sense to you? I have a feeling it does. Like that's the idea in problems like this is that X is an unknown number of years. And if I'm going forward in time, I add X. If I'm going backward in time, I would of course subtract. Now the math is like step 3 is just distribute. Like you could probably solve this in your sleep, right? How are you coming on assignments 42 and 43? Just the other dad joke worksheets. Okay. Who else has questions? Yes, sir. I just saw his first, so I'm going to go with Hayden. Sorry. I'm going to go ahead and throw out a guess that you probably let D equal Dorothy's age right now and R equal Rita's age right now. Okay. So tell me about the first equation. It literally just says Dorothy is. So we're talking present tense. What do you got for that? Perfect. So Dorothy is 14 years younger than Rita. Nailed it. Now, the key is mastering the next 5 words. And I'm going to put this up on the board in quotes because for anyone that's paying attention, I think like I would put this in my notes. When it says 10 years ago, comma, Rita was. Those words can be replaced, and they will be like predictably replaced with what? How old was Rita 10 years ago? This is kind of what I was talking to Tegan about, is that first off, how old are you? How old are you? Yeah, your age. 15? How old were you 10 years ago? Do you know what your brain just did, right? It took 10 away from your age. Like I just like I told him, you didn't count it out. Like you just know, right? The brain does things and we're just sometimes not even aware of what it's doing. Like if you said, like I'm 50, if you said what's going to be my age in 17 years, I would just say 67. Like I wouldn't count it on my fingers. Your brain is constantly doing math, whether you know it or not. And so if Rita is this old, 10 years ago, she was that old. If you ever want to go back in time, subtract. You want to go ahead, add. And in this case, this is not like problems 1, 2, and 3 because the ages are not given. The ages now are back to being the variables again. So all those yellow words that I have up on the board just got replaced with R minus 10 equals. Had it said 5 years ago, I'd have put R minus 5. If it had said in 6 years, I'd have put R plus 6. I'm just putting whatever I need to satisfy the situation. In this case, going back in time. And it says that 10 years ago, Rita was what? There you go. So 3 times as old as Dorothy was then. How old was Dorothy then? How old is Dorothy right now? How old is Dorothy right now? How old is Dorothy right now? It's that big purple thing on the board. She's D right now. You defined it. I didn't do step one because I assumed you did it, but I assumed somewhere on your paper you have this written down. You have let R equal Rita's age now. Please tell me you did this, and that you have let D equal Dorothy's. I shouldn't have skipped this step. I just assumed that you had this. Do you have this? So when I say to you, how old is Dorothy? Don't look at me like I have two heads. Say D. If I say how old's Rita, you say R. How old is Dorothy in 5 years? D plus 5. How old was Rita 3 years ago? R minus 3. Like for the duration of this problem, we know how old they are. They are D and they are R for the time being because we don't know what they are. You with me? So, how old is Dorothy right now? How old was she 10 years ago? Correct. So, right in here, got it? You think you got it from here? Okay. What else? Yeah, you bet. I don't think there's any chance I get through the day and not have this question asked about in every single class. So, first hour, they asked, third hour, you've asked. If you're not paying attention, you don't have to. But this is page 171, problem 7. And it's a unique situation because it's going to involve some fraction killing, which thank goodness we learned how to do that back in August and September. So here it goes. So to define my variables, I'm going to say, I assume that you use T and F, maybe? Okay, so I'm going to let T equal Tom's age now. And I'm going to let F equal father's age now. All right. So with that out of the way, now if I ask you how old is Tom, you don't stare at me, you say T. How old is dad? F, right? We clear? So the problem starts out by saying 5 years ago, Tom was. What's that going to mean? Equals. That completes the first uh, 5 words, right? Was 1/3. Good. Nice. So if you got that one right, I'm guessing you got the other one right as well. So it says that in 5 years, this. So your question is nothing to do. Honestly, most of the questions I get during this unit are always about how do I write the equations? Your question clearly is just a math question. So what we're going to do is we're going to slaughter the fractions. So we're going to take this top equation and we're going to monster bracket and multiply it by 3. And we're going to take the bottom equation and monster bracket fraction kill it by 2. And if we do that, just be aware, remember that when we multiply, the multiplier goes here and here and here, but of course it does not penetrate the parentheses, right? So our top equation winds up being 3t. So that's our first equation. So when all is said and done, you should wind up with a system that just looks like this. And this is one that might be good for elimination. Like I could take the top equation. Well, you don't want to eliminate yet just because we're not really, I mean, I guess you could. I just feel like it's a little premature to eliminate. Eliminating a number isn't going to do any good. Like the purpose of elimination is to make a variable go away, not a number. So I would manipulate things around because what I want are either the T's or the F's to die, and neither of them will at this point. So if you choose to go down the elimination pathway, then your top equation would be 3t minus f equals 10. I moved the f to the left and then I added the 15 to the right. You okay with that? I'm just trying to make it look the way we're used to for elimination. And then if I do the second equation, what would that one say? No, because it's coming across. Minus f equals, no, yes. And then it feels more like a regular math problem by doing it this way. Like you totally could have done substitution for the record, like whatever. So this is the kind where you're going to have to multiply either the top or the bottom by a -1 to get the f's to be eliminatable. Is that ringing any bells? You want to do the bottom? Sure. So if we take the bottom one and we multiply it by -1, then it'll change into -2t plus f equals 5. And then I can get rid of that. And now we got a fluffer puffer. So when we, yeah, 15, I think. If I add straight downwards, check your math, then I get 3t minus 2t is 1t. But last I checked, 10 plus 5 makes 15. Yeah, don't do that. Sure. That's a toughie. Do you have questions? Sorry. Did you add 30? And add 30. What's negative 10 plus 30?
Oh, would that be a positive 20?
Of course it would.
Okay.
Negative 10 plus 30 is not negative.
Yeah.
Hmm?